This is cumulative test 3A, so let's get started. All right, we need to find the measure of DEG, and they give us information concerning the other two angles here, DEF, which is 34, and FEG, which is 53 degrees. So we need to find the bigger angles. That would be adding these two together. 34 and 53 is 87 degrees. Therefore, the measure of DEG equals 87 degrees. Classify the angle. That means, is it obtuse? Is it acute? Is it straight? What is it? Well, 87 degrees means it's acute. Okay, that's what we do. Number 2, determine the values of x and y in the diagram. So there's x, there's y. So we look at this whole thing, and they're giving us pieces of information that we can use. The cumulative addition of all these angles is going to equal this line. The line equals 180 degrees. They also tell us that two of these angles add up to be complementary, and that makes a 90-degree angle right there. So we can really start with that information and then move over to figure out what x equals. So y is going to equal, y plus 25 equals 90 degrees. 90 degrees, because that's 90 degrees. 90 minus 25, and if you just do that carefully, I'm sure you can do it in your head. Is 65, and you go add that to it, 80 and 5 and 5 is 90, so that's accurate. These three added together and subtracted from 180 will give you x. Finding x, we'll just come over and add the 3 together. We'll get 125 degrees. And then you subtract that from 180. Should come out to be 55. If you subtract that from there, that's 55 degrees. So x equals 55 degrees. All right. Identify coplanar, non-coplanar lines in the diagram. Looks a lot like another test we had. You have crossing lines. D and E are crossing. Anytime you have two lines, even if they're, for that matter, parallel, they're going to be coplanar. But these cross, so they are coplanar. So D lines, D and E are coplanar. And then there are no non-coplanars lines. They have to be coplanar. 4, find a counterexample to this conjecture. If a quadrilateral has two pairs of congruent sides, then it has to be a parallelogram. Well, counterexample would be a kite. Kite has two pairs of congruent sides. There's these two are congruent, these two are congruent, but the kite is not a parallelogram. So that's your counterexample, a kite. The base of a triangle measures 5 inches and its area is 13.2 square inches. So we need to determine the height from that. Okay, I worked this out beforehand. The formula for the area of a triangle is 1/2 base times height. They give us parts of that. They give us the base and they give us the area. So that's what we're going to work with. Substitute 13.2 for the area and 5 for the base. Plug those in and it becomes just an algebra solution problem. We're going to find this variable h. So we're going to multiply both sides by the reciprocal of 1/2. That's what we're doing here. If you do it over here, it disappears, of course. We'll multiply that, and you get, 5h equals 26.4. And then we're going to divide both sides by 5. When you do that, you get h equals 5.28. So both sides need to be divided by 5. And you get h equals 5.28. So the height is 5.28. If you plug that back in, this times 5 divided by 2, you're going to get 13.2. They want you to prove the lines A and B are parallel. Well, these will be parallel if alternate interior angles are congruent, alternate exterior angles are congruent, corresponding angles are congruent, or you have supplementary same side interior angles. These are alternate exterior angles. So alternate exterior angles are congruent. That proves that these are parallel. Use inductive reasoning to determine the next term in the series that you have before you there. Now the pattern that I see here is between these is 2, and these are 4, and the number between these is 8. So it looks like we start at 2 and we're just doubling. 2, 4, double 4, 8, double 8, 16, double 16, 32. As you do that, you're adding them. So 30, we get up to 32, 32 and 33 are 65. Double 32, you get 64. 64 and 65 is 129. Number 8, we find that Michael wants to carpet his living room floor. The floor is a rectangle, so I drew a rectangle. Its dimensions are 16 by 21. I need to find the area of that rectangle, which represents the floor. So to do that, it's 21 times 16. 21 times 16 equals 336 square feet. That's how much carpet he needs. Number 9, I want to prove that again. We're proving lines parallel. Prove these are parallel. So we need alternate, either congruent alternate exterior angles or congruent alternate interior angles or congruent corresponding angles or supplementary same side interior angles. I see here I've got 125. I know that these two are a linear pair, so the difference between 125 or subtracting 125 from 180 is going to give me 55. I know that. So I also now see that I have alternate, or AIA, alternate interior angles are congruent. So I've just proven, because there's a theorem for that, I've used that theorem to prove that these are parallel. Okay, 10, you're supposed to calculate the distance between the 2 points. You're going to use the distance formula. Distance means distance formula. So the difference of the x's, that's 3 and negative 1, so 3, I'm just going to write the minus minus so we don't forget about that, squared, plus negative 8 minus minus 11 squared. I've set up the distance formula, and what I've done, I've plugged in these points into the distance formula. So 3 minus minus 1 and negative 8 minus minus 11. All right, so that's set up. Now, we'll go ahead and rectify that. That becomes a plus. This becomes a plus. And this becomes 4 squared plus 3 squared. And 16 plus 9, which equals the square root of 25. which equals 5, and that's your distance. Number 11, we need to determine whether this conditional statement is true. If it's false, give an example. So an example would be a counterexample. If Jane lives in the United States, then Jane lives in Arizona. Okay, of course that's possible. She could live in Arizona. She would be in the United States. But it's false because what if she lives in our state, Florida? Right? I mean, Florida's the United States. So if Jane lives in the United States, she could live in Florida. It's not just Arizona. So we have, as far as the United States, we have 49 other possible states, at least, that she could live in. So Florida is a counterexample to, Arizona. That's, good enough. Lines A and B are parallel. All right, now we're told that these guys are parallel. Those are conditions. Find the angle CLM. All right, so we're going to work on that real quick. Okay, so this is involved, so I've done some covering up as I did the pre-works in order to save time. I don't have to spend a lot of writing time, but we're told that these two lines are parallel, and we want to find this angle right down here. Okay, so I'm going to work to doing that. I need to figure out what X is, and then I can work to figuring out that angle. Now, these two angles are vertical. They're vertical angles, so they're congruent. So this is 4x plus 5, because that is. These two, I know, have to be supplementary because I'm told that the lines are parallel. So these are supplementary. 4x plus 5 plus 2x plus 25 equals 180. Now I come over here, and I've set that up. I've added 4x plus 5 and 2x plus 25. They should be 180, and I can solve for x now. So I work my way down. You can pause and follow the work. I didn't do every step, but basically you work down to 6x equals 150, therefore x equals 25. Now that helps me now. I'm not done, but I come over here. I want to find this angle. Notice I've written in 2x plus 25 here. That's because it's vertical to this angle, because these are crossing lines. I can plug 25 into x. I did that over here. And 2 times 25 is 50 plus 25 is 75. All right, so that angle is 75, therefore that angle is 75. Now, I want to check it. I know, if this is 75, hopefully these two would add up to 180 because they're same side interior angles. 4 times 25 is 100 plus 5 is 105. So that equals 105. This equals 75. These two added together equals 180. All right, so you can carefully do the math and see that. It all checks out. This is a midpoint problem, term midpoint of this segment with the segment that contains these 2 points. We're going to do the average of the x's, -2 plus -8 over 2. That represents your midpoint x, and then the average of your y's, 3 plus 4 over 2. And okay, we'll just say that equals, carry these over here. -2 and -8 is going to be -10 divided by 2. Maybe I'll just work it down here. -10 divided by 2 is going to be -5. All right. 3, that's not a negative. That was just me putting my pencil there. 3 plus 4 is 7 divided by 2. So if you do the math on that, 7 divided by 2 is going to be, what, 3.5? All right. So our midpoint is located at -5 and 3.5. Our next problem is we have a rectangular computer screen. Looks like this. Right? And the it says it's measured by the length of one of its diagonals. There's a diagonal. That's how we determine the size of computer screens or even TV screens. What's the size of the computer screen? All right, we need to know the length of that diagonal. We're told that one dimension is 12, the other is 9, so that's 9 and 12. And we're going to do Pythag, 9 squared plus 12 squared equals, that's going to be our diagonal. I'll just call it c squared. So that's 81 plus 144 equals c squared. Okay, I've worked that down. These are squared. Add these up, and we get 225. You can square root both sides, and that gives you 15 equals c. There's our answer. So this dimension, the diagonal, is 15 inches. This problem, you need to measure the angle and then determine whether what its classification is. All right, right here. Okay, so we've got to measure this. We're going to extend our lines. Gives me enough length, I think, to measure it. Okay, see how I'm putting that right in the window there, lining up this line. This comes out to 0, 10, 15, 16, depending, we'll just call it 16 degrees. And it is acute, that's the classification. All right. 16, we're to determine the midpoint of the line segment AB, connecting this point and this point. All right, so that's another midpoint problem. So we're going to get that set up. All right, we've got it set up. For the midpoint, this would represent your x. This is your y. Notice I've done -3 plus 4.6 divided by 2, and then 5.2. And I went ahead and carried the negative over it and said plus -2.2 divided by 2. That's like saying minus 2.2. So you do the math on that, you get 1.6 over 2 and 3 over 2. And your midpoint's 0.8 and 1.5. Right, we're to determine whether this polygon, JKLMN, is convex or concave, and then explain. Well, I know that this diagonal between the point L and N is on the exterior of the polygon, so diagonal LN, and it's a segment, is exterior. Therefore, it is what? Yes, concave. Now we can see the cave, but that's the reason why we can say it's officially concave, is because it has a diagonal on the exterior. Determine the perimeter and area of triangle ABC. Now, triangle ABC is this triangle. Let's see here. You got to see the triangle. It's ABC. They give you a dimension that's not part of the triangle. So there, just so you can see the triangle. We'll make a mess of this. So I've done the setup here. Again, we've outlined this in red so we can see what we're working with. The perimeter is just going to be the length of all three of these sides. So these are length 16, 21, and 11.2. And so I add those together. And so I've got three sides that I add together, and I get 48.2 2 centimeters for the perimeter. And then for the area, I'm going to use the area of a triangle, which is 1/2 base times height, which is going to be the base of 16. I'm using that as my base. And if you come over here, this length is the height. So I'm doing the height times the base, 16 times 8 divided by 2. It's important, though, to understand that that's the height. This is the perimeter. I mean, the side. This is not a side, but it is a perpendicular measurement to this base. So you have to use a measurement that is perpendicular to one of the bases, and that gives us that. So the calculation then is 64 square centimeters. All right, 19 says to state the hypothesis and conclusion of the conjecture if the product of two integers is divisible by 6. That is the hypothesis. So you could indicate that by writing hypothesis there. Then one of these numbers is divisible by 3 and the other is divisible by 2. That would be the conclusion. The next part of the question is to answer whether the conjecture is true or false. So if we look at this, go back and go over it just briefly. If the product, that means you're multiplying of two integers, so integers, that would be in question. If their product is divisible by 6, right? So that's one test. Then one of these numbers, one of the integers, is divisible by 3 and the other is divisible by 2. So if you can find two integers that don't meet those requirements, then and you have a product divisible by 6, then it's false. If you look at 6 times 5, 6 times 5 is 30. Obviously 30 is divisible by 6. The two integers are 6 and 5. 6 is divisible by both 3 and 2, but 5 is not. So one of these has to, each of these have to fulfill the requirement. So it's false, and it's for those reasons. Find the counter example to the conjecture. The sum of two integers, the sum of any two integers that are greater than 1 is less than their product. Now this is kind of complicated, but we need to find a counterexample to prove that false. All right, the sum of any two integers greater than 1. That means the two integers will be greater than 1. So I found 2 and 2. 2 times 2 is 4, and 2 plus 2 is 4. So they say, the test is the sum of any two integers is greater than 1 and less than their product, and that's why this is false.